Welcome to English Learning Podcast, Throw Science.
Today we're tackling something truly elemental, volcanoes. We've got your source materials right here, and our mission really is to unpack all that information. We want to pull out those key nuggets of knowledge and maybe find some surprising facts about these fiery mountains that are always changing our planet.
Absolutely. And it's such a great topic for this because, volcanoes aren't just about destruction, not at all. They're actually fundamental to understanding Earth's geology. I think this dive will really show their dual nature. Hugely destructive, yes, but also incredibly creative in some really fascinating ways.
Okay, right. So let's maybe start with the basics, just to ground ourselves. When we talk about a volcano, what are we actually talking about? It's an opening, right, in the Earth's crust.
Exactly. An opening that lets molten rock, gas, ash, all that stuff escape from below the surface.
So for you listening, what's the key difference in those substances? Like, what are we seeing when it comes out? Is it all the same?
Well, no, and that's a crucial distinction the sources make. You've got magma, right, the stuff underneath.
Yeah, molten rock beneath the surface. Then, when it erupts and reaches the surface, we call it lava.
Okay.
And this might seem basic, but it's really important. That change, as magma comes up, losing gases, cools down, that transformation dictates pretty much everything.
How so?
Well, it determines the volcano's eruption style, how sticky or runny the lava is, how far it flows.
Yeah.
Essentially, its whole personality and its destructive potential. It's more than just a name change. It's a whole physical and chemical shift.
That makes sense. So that sets up the next big question then.
Yeah.
How do these incredible things actually form? Where do they come from?
Right. So the sources are clear. Volcanoes mostly form where tectonic plates meet. The Earth's crust is broken up into these huge plates.
Yeah, always shifting around.
Exactly. And how they meet is key. It's not just that they meet. Are they pulling apart? Like at divergent boundaries. That lets magma well up, creating maybe those huge underwater ridges or shield volcanoes like you see in Iceland. Or is one plate diving under another, a subduction zone. That process generates the stickier magma that leads to those really explosive stratovolcanoes that people often imagine. The mechanics of that interaction define the type of volcano you get.
Which is a perfect transition because the sources really stress that volcanoes aren't all the same. Not even close. We're talking very different types.
Definitely. The sources highlight three main types, and it really comes down to the magma inside them. First, you've got shield volcanoes.
Okay, shield, like flat.
Yeah. Picture a warrior's shield laid flat on the ground. They're broad with really gentle slopes. Mauna Loa in Hawaii. Classic example. Their shape comes from very fluid, runny lava, low viscosity that just spreads out easily over huge distances before it cools and hardens.
So wide, not tall. That runny lava defines them. That's quite different from the usual image, isn't it?
It really is. And that contrast takes us straight to the second type, stratovolcanoes, sometimes called composite volcanoes.
Ah, okay, they sound like the classic ones. Steep, cone-shaped.
Exactly. Like Mount Fuji in Japan, that iconic shape. They're built up over time from alternating layers, lava flows, ash, cinders, other debris. Their magma is usually much thicker, more viscous. It traps gases.
Which means bigger booms.
Precisely. That trapped gas leads to the potential for those really explosive, powerful eruptions we often associate with volcanoes.
Right. Okay, so shield volcanoes spread out, stratovolcanoes build up explosively. What's the third type mentioned?
The third type are cinder cone volcanoes. Now, these are generally smaller.
Smaller how?
Well, they often form on the sides of larger volcanoes or sometimes just pop up on their own. They're built from fragments, loose volcanic material called cinders. Think of explosive eruptions, but the stuff throwing out particles, blobs of lava, cools quickly and piles up right around the vent, forming a relatively small, simple cone.
So less about flowing lava or massive layered buildups, more about like a fountain of fiery rocks piling up.
That's a good way to put it. Rapid fragmented accumulation. So you have the gentle flows of shield volcanoes, the explosive layers of stratovolcanoes, and the quick fragmental buildup of cinder cones. Different magma, different styles.
Okay, that paints a clear picture of the types. But what about their impact beyond just being there? The sources mention some really surprising effects, right, on the whole planet, even the climate.
Oh, definitely. The atmospheric impact can be huge.
Yeah.
Eruptions release enormous amounts of gases. Water vapor, sure. CO2, yes. But also, critically, sulfur dioxide.
Sulfur dioxide. Why is that one so important?
Because when it gets high up into the stratosphere, it converts into tiny sulfate aerosols. These little particles act like mirrors, reflecting sunlight back into space.
So they cool the planet.
Temporarily, yes.
Yeah.
The sources give a fantastic example. the 1991 eruption of Mount Pinatubo. It pumped so much sulfur dioxide up there that it actually cooled global average temperatures for about 2 years. It's a really stark demonstration of how volcanoes can influence global weather.
Wow, okay, that's a major impact. But it's not all negative, is it? I remember reading something about benefits, like for the land.
Yes, absolutely. It's easy to focus on destruction, but volcanoes are also creators. One huge benefit is creating incredibly fertile soil.
How does that work? Volcanic rock doesn't sound very farm-friendly.
But when that fresh volcanic ash and rock breaks down what we call weathering, it happens relatively quickly, and it releases a ton of essential plant nutrients: potassium, phosphorus, nitrogen. Stuff crops love.
So the ash is like a natural fertilizer.
Exactly. The sources point to places like Indonesia or parts of Italy near Vesuvius. People live near these volcanoes, despite the risks, partly because the land is so incredibly fertile that volcanic soil helps feed millions.
That's a fascinating trade-off, fertility versus danger. Which brings us back to the risks, because we can't ignore them. They're incredibly powerful.
Extremely. And the dangers are varied. The sources detail quite a few. You've got the obvious lava flows, maybe slow, but pretty much unstoppable.
Right, they just keep coming.
Then there are pyroclastic flows. These are terrifying. Superheated clouds of gas and volcanic debris, rock ash, racing downhill at hundreds of miles per hour, just incredibly destructive and fast.
Okay, that sounds impossible to escape.
Virtually. Then you have ash clouds that can spread for huge distances, grounding airplanes, causing respiratory problems, and lahars. These are destructive mud flows, basically. Volcanic debris mixes with water from melted snow or rain or rivers and flows down valleys like wet concrete, burying everything.
So multiple ways they can be devastating. But you mentioned earlier that a lot of this activity, we don't even see it, right? Most isn't on land.
That's a crucial point, and maybe one of the biggest eye-openers from the sources. The vast majority, something like over 75% of all volcanic activity, actually happens underwater.
You're underwater, 75%.
Yet mostly along the mid-ocean ridges where tectonic plates are pulling apart. It's happening constantly, hidden beneath the waves. This underwater volcanism is fundamentally how new oceanic crust is formed. It shapes the entire seafloor. And over long timescales, it builds underwater mountains that can eventually emerge as new islands.
So most volcanoes are silently building the ocean floor, and sometimes new land, completely out of sight.
Exactly. It's this continuous, unseen engine driving planetary change and creation.
Wow. Okay, so wrapping this up then. We've kind of unpacked the basics, the different flavors of volcanoes, their huge impacts, cooling climates, creating fertile soil, and also the dangers, plus this whole hidden underwater world. It really hammers home just how dynamic and powerful our Earth is, constantly changing.
It really does, and it reinforces that core idea we started with. Volcanoes destroy, yes, but they also create. That duality is just central to how our planet works, how it continues to evolve. They play such an essential role.
Well, thanks for joining us on this deep dive today. We really hope you, listening, feel a bit more connected to this fiery heart of our planet.
Yeah, so maybe next time you hear about an eruption, or just see a volcano in a picture or on a map, think beyond the immediate explosion. Think about those unseen forces, that constant cycle of destruction and creation. It's shaping everything, from the deepest oceans to the highest mountains, influencing the soil we need for food, even the air we breathe. It really makes you think differently about the ground right under your feet, doesn't it?